Hello everyone, this is Mayuk Mazumdar and I'm back with another exciting session. So let's proceed.
Hi, in this session, I'll be introducing you to class. Classes provide a means of bundling data and functionality together. Creating a new class creates a new type of an object, allowing new instances of that type to be made. Each class instance can have the attributes attached to it for maintaining its state. Class instances can also have methods for modifying its state. Okay, right now I defined a lot of heavy terms. Let me break that down. So one of the most simple use case that I can think of describing class will be that of an object that is a person. So suppose person is my broader class. Now this person has some properties, that is it can have black hair, black eyes, it can have any skin color, it can have a height, or it will have a height definitely, and it will have some weight, and it will have some behaviors definition, that is it will eat, it will sleep, walk, play, or study, any of them. Maybe study more and play less, or vice versa, anything. Now, so this is my object person, that is my class. Now I can create objects of this class. By doing so, it gives me the liability to define x, y, z persons, which are objects of the class person. So I can maybe define from that class person, I can make an object of that class, and now I can add variable value, their separate values to the properties and their behaviors, and can combine some or remove some to make a new person. For example, the hair color can be allowed to brown, the eye color may be sky blue, the skin color may be anything, the height may be 5 feet, and the weight may be 70 kgs. So these are the values of the properties or the state of the object class, means of the class person, and I can assign the behavior or action of that object, as I can call the methods eat, sleep, walk, play, study all together, or I can even remove one or two or add new more. So by doing so, what am I doing? I am creating an object of class person, but the value of the states are quite different from one another. I can similarly create another person with hair color maybe white, and the eye color may be dark brown, the height may be 7 feet, and the weight may be 90 kgs. And the behavior, out of the behavior, he eats, he sleeps, he walks, and he plays. He doesn't study at all. So that's a completely separate person. So from that class person, I am defining an objects, and I am assigning the values of the variable that it takes in a separate manner, and hence we come up with the entire new separate person. So that's the main concept behind class. Compared with other programming languages, Python class mechanism adds class with a minimum of new syntax and semantics. Python classes provide all the standard features of object-oriented programming. The class inheritance mechanism allows multiple base classes. A derived class can override any method of its base class or classes, and a method can call the method of a base class with the same name. Objects can contain arbitrary amount and any kinds of data. As is true for modules, classes partake of the dynamic nature of Python. That is, they are created at runtime and can be modified further after creation. So as I said, I can add more behaviors to that person, or we can remove behaviors of the existing definition of the class, and we can play with it. So that's the power of classes. The next section I would like to talk about is the Python namespace. Now, before introducing classes, I first have to tell you something about Python's namespace. Class definition plays some neat trick with namespace. and you need to know how scopes and namescapes work to fully understand what's going on. Let's begin with some definition. A namespace is a mapping from names to objects. Most namespaces are currently implemented as Python dictionaries, but that's normally not noticeable in any way, and it may change in the future. Examples of namespace are the set of built-in names, that is, containing functions such as apps and built-in exception names, the global name in a module, the local name in a function invocation. In a sense, the set of attributes of an object also form a namespace. Now, let me show you quickly the class definition syntax. The simplest form of class definition looks like this. That is class, my class, or class, the average student. And over here, I can define def A, blah blah blah, then def B, sorry, not bool, blah blah blah. So that's the basic definition of a class. Now, when a class definition is entered, a new namespace is created and is used as the local scope. Thus, all assignments to local variables go into this new namespace. So this function A and function B belongs to the class the average student, and this all exists in the local namespace. Now, when a class definition is left normally, a class object is created. This is basically a wrapper around the content of the namespace created by the class definition. So the next thing is class objects. Class objects support the two kinds of operation. One is attribute reference and instantiation. Attribute reference uses the standard syntax for all the attribute of reference in Python, that is some object.name. A valid attribute name are all the names that were in the class namespace when the class object was created. So maybe class the average student, it has some variable named as I, and it is initialized to value 9999. Now it has a function that is sample, and it accepts the self variable, and it returns simply hello world or hello average students. Okay, now over here the average student dot I and the average student dot sample are valid attribute references, returning an integer and function object respectively. Class attributes can also be assigned to, so you can change the value of the average student dot I by assignment __ doc __ is a valid attribute, returning the doc string belonging to the class. So maybe now what is a doc string? So I'll be adding a doc string to it. So that's a sample class used for preaching Python. So __ doc __ will return me the doc string of that class. Now let me create an object of that class. How can I do so? So let me say obj is my object name, obj equal to the average student and open close parenthesis. So here the obj is the object of my class. Now using this, I have created a new instance of the class and assigns the object to the local variable x. The instantiation operation, that is calling a class object, creates an empty object. Many classes like to create objects with instances customized to a specific initial state. Therefore, the class defines a special method named as init. So, let me define the init function. My mistake. So I have defined this init function, and maybe I am defining a list named as data using this definition. So when a class defines an init method, class instantiation automatically invokes the init method for the newly created class. So in this example, when I create a new object of the class, so a new initialized instance can be obtained by this definition. Of course, the init method may have arguments for greater flexibility. In that case, arguments given to the class instantiation operator are passed to init. Now, for example, maybe init has some variable that is maybe for a complex number, the real part of the complex number and the imaginary part of the complex number. So let me initialize those two self variables. So self dot real is equal to real part and self dot imaginary equal to the imaginary part. Now I will be creating an object of the average student and will have to pass some arguments. So maybe that can be done so by this. So I've passed this to variable, and as you can see, this to variable will be passed to the init method, where the real and the imaginary this variables will be initialized with this value, and they will be assigned to the self variables real and imaginary. So now when I would like to print the real value the value of this real variable, the self variable, so let's see what it prints. Also I would like to print the imaginary variable as well as of this class. And how do I access? So I access that using this object that I've just defined. So as you can see that the real and imaginary value have been sent to values 3.0 and minus 4.5 as I have passed as an argument to this init function. Now, instance object. What can we do with the instance objects? The only operators understood by instance objects are attribute references. There are two kinds of valued attribute references: name, data attributes, and methods. Now, data attributes correspond to instance variables in Smalltalk and to data members in C++. Data attributes need not be declared with local variables. They spring into existence when the first assignment is done. So, let's say that we are not accepting any variable as such for this use case. So I'll bunk this section. Sorry. So let me just simply define a self dot data maybe as a list, and also this assignment won't work anymore, and these variables also do not come into existence. Now when I do so now I will be calling this method sample using this object. So whenever I call that method sample, so it should return me hello average student, and when I use this within the print block, so it will print the output, and it prints the hello, means it returns hello average student, which is being printed, whereas this function do returns a string. Now it is not necessary to call a method right away. Now over here, object.sample is a method object and can be stored away and can be called at a later time. So whenever we will be using them. Now, what exactly happens when a method is being called? You may have noticed that the object.sample was called without an argument above, even though the function definition for sample specified an argument. What happened to the argument? Surely Python raises an exception when the function that requires an argument is called even without any, even if the argument is not actually used. Actually, you may have guessed the answer. The special thing about method is that the instance object is passed as the first argument of the function. In our example, the call object.sample is equivalent to the average student.sample of x, any variable. In general, calling a method with a list of n argument is equivalent to calling the corresponding function with an argument list that is created by inserting the method instance variable before the first argument.
The next thing that we'll be going over is class and instance variable. Now, generally speaking, instance variables are for data unique to each instance, and class variables are for the attributes and methods that is shared by all the instances of the class. For this, let me define a sample class example. So over here, what I have is my class dog, and it has a variable that is the variable name is kind, and it's initiated to canine. Now I have an init function in it which accepts a name, and that's an instance variable which is unique to each instance. Whenever we create an object of this class dog with a name, so this name variable will be unique to each object. Now I'm creating two objects. One is d, which creates an object of the class dog with the name Fido. Now this Fido name is assigned to the variable name, and another object is being created with the name e, which has the name variable value passed as buddy. Now let me show you how it works. So if I'm going to print d.kind maybe, so let's see what the output says. So it says it's canine. So by this kind I meant this variable which have been defined, and now this is the shared variable. So this is the class variable which is shared by all the objects of the class, and it will be same for all the objects. So let me show you again. Now if I print e.kind, let's see what it does. See, both have been printed as canine. So this variable is being shared, and it's a class variable which is being shared by both the objects, or how many objects, whatever we may define. Now what are the unique components of an object? So if I do so, let me print d.name and also print e.name. Now when I do so, let me run the script. Yeah, so when I do so, you get to see that these names are unique to each object. That is, they are the instance variable which is unique to each instance. So this was about instance variable and the class variable. Now the next thing we'll be talking about is inheritance. We have also encountered this term in the first session, but let me go back. So inheritance in Python, of course, a language feature would not be worthy of the name class without supporting inheritance. The syntax for a derived class definition looks like this. So let me write it down. So if we create a derived class, so maybe derived class 1, and it means it is instantiating from the base class whose name may be base class 1. Then since it's not defined, so it's giving an error, but let it be. So then we give any statement we feel like in the class, and then we finish with the statement. Not if, sorry, my bad. Yeah, so statement 1, 2, maybe statement n. So that's what I was saying about. So this is the format. Now the name base class name must be defined in a scope containing the derived class. See, it's giving an error because it has not been defined. So let me say that I am defining a class named as Tommy, which derives from the class dog, and now I define something within that. So say the base class name must be defined in a scope containing the derived class definition. In place of a base class name, other arbitrary expressions are also allowed. This can be useful, for example, when the base class is defined in another model. Suppose maybe I would have been calling from another object or another class. So that could have been that class name dot the means suppose session 6 I may be calling it from session 5 package. So session 5 dot class name should have been my session 6 dot base class name should have been my definition. Now, execution of a derived class definition proceeds the same as for a base class. When the class object is constructed, the base class is remembered. This is used for resolving attribute references. If a required attribute is not found in the class, the search proceeds to look in the base class. The rule is applied recursively if the base class itself is derived from some other class. Now, the next topic is iterators. So, by now you have probably noticed that most container objects can be looped over using a for statement. So, we have seen for loops. Now, let me just show you. Maybe for each in maybe a list containing 1, 2, and 3. So, if I print each, let's see what happens. Before that, let me comment out this section. Yeah, so see, I've iterated over each element in this list, and the last component for today's lecture is the generators. Now, generators are a simple and powerful tool for creating iterators. They are written like regular function, but they use the yield statement whenever they want to return data. Each time next function is called on it, the generator resumes where it left off. That is, it remembers all the data values and which statement was last executed.